more important than 11.1. Okay? Because 11.1 is also included, because series is more important. So, because we only have this class, and next class for the exam. So we need to try to finish at least the one. Okay? So let's start with series. Now, series definition. Series are some of So, for example, I want to find the sum of n equal 1 to infinity of this series. How do I do that? I look at the first, for example, few terms. 1 over 2. This is plugging n equal what? 1. And then plug n equal 2, you get 2 over 3. And then plug n equal 3, 3 over 4, and so on. So this is how you read the series. Okay? This is how a series actually looks like. Expanded. Now, we don't need to expand this, okay? Now, what we want to do is figure out if a series is convergent or divergent. You know the convergence, divergence? Okay. The same thing in improper integration. What does convergent mean? A finite number, and divergent mean plus or minus infinity. Okay? Alright. So let me show you the big picture here. Okay? We have two big types of series. We have series that we can evaluate the exact sum of. We can evaluate the exact sum. So this thing here, the infinite sum here, I can know what number it is exactly, for example. Okay? There is one type of series like this. And another type of series is we cannot find the exact sum of. Okay? It's like 7.8 when we did what? When we had a section of evaluating the integrations. We were doing the integration, substitution, bypass, blah, 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 and we were putting t and limit and all of this. So this is exactly like similar to this part. And then here, we said the second part of the section was what? If we cannot integrate, so what do? We do tests. We did DCT. So this is one of the tests. In series, you have multiple tests, okay? So now, for example, in the exam, they will tell you, there will be a question, find the exact sum of the series. So we're working here, right? In here, I have two types of series only. Geometric series and telescoping series. We'll talk about this more today, okay? And then if we cannot find the exact sum, then we use tests. In this exam, we have 3 tests, or 4 tests. Divergence test, and then DCT, the same one we did in 7.8, and we have LCT as well, and we have alternating series test. So if he said in the exam, find the exact sum of the series in any wording, then it's either this one or this one. Okay? If he said find if it's convergent or divergent, I use any of these 4 tests. So what I'm gonna do today is these. Focus on these as much as we can. and then these ones will do next. Okay? Right, okay. Let's talk about geometric now. Geometric series. How does it look like? Okay? Geometric series have a specific form. They have a specific form. That form is summation, some constant, multiplied by some constant, power n. So C and R here are constants. N equal 1 to infinity or whatever. Okay? Alright. So I can know when a geometric series converges. When does a geometric series converge? Converge, let me write it here. This converges if absolute value of R less than 1 and diverge if absolute value of R larger than or equal to 1. Okay? If it diverges, the sum is like infinity or something, right? So we don't care about this. But if it converges, I can find the exact number. Converges to what number? Okay? So if it converges, the sum is the following. S equals A0 over 1 minus R. R is the ratio here, power n. The number that is to power n in the question. And A0 is the first term in the series. How do you find the first term in the series? How did I find the first term in the series? I plugged the starting position, right? I plugged n equal 1 in here to get the first term. That's what we need. Okay? Okay. Let's do examples. Better? Let's do examples.
So Professor, the first term, which is
What?
this one is 0, it's like a 0, right?
It's not a 0, no. It depends on the question, I don't know.
No, I'm saying
A0?
yeah.
Yeah.
You replace it with the first term we have. Yeah.
In the series?
Yeah.
Yeah, exactly. We'll do that now.
It's A0 all, right?
What do you
A0 equals whatever is there.
The first term, yeah.
Yeah.
In that example, it was, I think, half.
Yeah.
In the first one, yeah, exactly. So you replace it with half. Depends on the question. So, example, find the sum of the following if it exists. Following if it converges. Yeah? You can apply this formula only if it converges. Because if it diverges, what's the sum? Infinity. Okay, again, so what do we do here? Let's take this. Yeah. Okay. Why is this a geometric series? Because you have some numbers power n, right? Yeah? But is it written exactly on the form that I need? No, it's not. So what do I need to use algebra, pure algebra, to make it on the form that I need. What are the algebra rules that we have? X power A times X power B is A plus B. X power A divided by X power B, XA minus B. X power A power B, XAB. Yeah? Then this xy power n, for example, x power n, y power n. And so on. What else? X negative A is 1 over x power A. These algebra of exponents, you need to remember these. Okay? Alright, so let's try using these rules to make everything power n. Not 2n, not n minus 1, n. Yes, the whole thing. Okay, so let's break this down then. 4 power 2 power n. Which rule did I use here? This one. Yeah? Pi power n multiplied by pi power minus 1. Right? and then n equal 1. Now, pi power minus 1, you can flip its position and make it positive, right?
It's a constant.
So it becomes, yeah, it's a constant. Pi here, power 1 on the top, times 4 squared, I know that it's 16, divided by pi power n. Am I right?
Yes.
Is this on the form or not yet?
Yes.
No, almost. Almost.
We need to.
I need to take now n as a common power.
Yes.
16 over pi, all power n. Now this is exactly on the form. C, r, power n. Now I can read it. What's r? R is 16 over pi. Can someone tell me if this number is less than 1 or larger than 1?
Larger.
It's larger than 1. So does this series converge or diverge? Diverge. Series is diverge. So can I find the sum? No, I cannot find the sum. Because it's infinity. Yeah? Good. This is like,
But then we need to apply a test, right?
huh?
We need to apply a test.
No, I just answered. It's divergent.
Oh, okay. When do we apply the test on the question?
If
asked?
you don't know, if it's, yeah, if it's not geometric or telescopic, you apply. Okay? If it's geometric or telescopic, you use the theory for them. Like
Okay.
the rules for them separate. This is separate, this is separate. Okay? Let's do more. Let's do something. Minus 1 power n, 5 power 2 n plus 1, and power divided by, I don't know, yeah? 4 power, okay. And n starts from 0. Okay, again, so the first step is to make everything power n. Not n2, not 2n plus 1, for example, right? Okay, so how do we do it here? Minus 1 power n, 5 power 2n, times 5 power 1, right? Divided by 3 power n. This is a constant. This one, I don't need it, I don't like it, right? How do I do it? 5 power 2, and then all power n. 5 power 2, and then all power n, and then divided by 3 power n. If you want, you can take the constant here at the beginning. It's fine, it doesn't affect. Okay?
Now we can take the n out.
Now you can take what? Do you agree that I can take n as a common power? Because everything now is to power n, right?
Yes.
Single n, not 2n, not 2n plus 1. Now I can take it down. So it's going to be 5, and then minus 5 squared over 3. All power. And now what? What's r?
Greater. Greater.
Yeah? Absolute value of r is greater than 1, right? Absolute value. Do absolute value, please. So pi squared over 3. So greater than 1, so series divergent. One more. That's everything. 2 negative n plus 4 negative n divided by 3. Less than 1. Okay? How do I do that? What is this?
Use absolute.
What do you mean use absolute? I need to break it. I need to write the series in terms of something power n, right? But can you take n as a common factor here from the top? No. There is addition, right? So this is a big problem here, right? You agree that the addition is a big problem here? Can we get rid of the addition?
Can you split it?
How to get rid of addition?
Can we split?
Split. Yeah? If I want to overcome addition, I split. So let's split. Look how is that going to help you. 2 negative n over 3n plus another series, you can say 4 negative n over 3n. Now I can use exponent rules nicely. I can just directly take these down, right? So what does it become? 1 over 2 and 3n plus 1 over 3n. Can I now take n as a common power? Yeah? What does it become?
1/6
Plus 1 over.
12.
Is this on the phone now? No. We have a problem. What do? We can use a simple fact. That 1 is the same as 1 power n.
Yes.
Right? Isn't that a true statement?
Yes.
So can I say this is power n? And this is power n?
Yes.
Can I now take n as a common power from everything?
Yes.
Yeah? 1 over 6, all power n, plus 1 over 12, all power n. What do I do now? I check convergent or divergent. Now it's written on the phone, right? So I check if it's convergent or divergent. How much is r here? 1 over 6 less than 1, convergent. How much is r here? 1 over 12 less than 12, convergent. So both converge.
So I don't care about the plus sign, right?
Yeah.
Yeah.
Look, you deal with every series separately.
Because we split it.
Yeah? Good. Okay.
Professor,
If one of them diverges,
then it's divergent.
the whole question diverges. Yeah? It makes sense. One thing is infinity, one thing is finite. The whole thing is infinity. Logo. So now I'm not done yet. I said if it's convergent, find me the sum.
Right. You take the first one.
How do you find the sum? S equals, let's do this sum plus this sum. Right? Okay. 1 minus r and 1 minus r. Right? What's the first term in this series? You plug the first index. What do you get? 1 over 6 power 1. What's the first term?
Over 12.
1 over 12. خلاص, I'm done. This is a number you can do on the calculator, it's fine. Okay?
Professor, if there was a minus between them, we do the same, right?
You just do minus. Yeah. So it'll be this guy minus this guy.
No, I mean we split and
Yeah, yes, yeah. Same thing, same procedure. Okay.
Professor, if there was a constant, you have to account for it, right?
Yeah, like if there is 2 here, there is 2 here, okay. Plug 1, what do you get? 2 times 1 over 6. So you copy 2 times 1 over 6, you put here. That's it.
Professor, if you can just explain to me that step there. Yeah.
This one?
After this. Yeah.
So this you get or no?
No, no.
You don't get how it
That's
is.
this one.
Okay, from here. Okay. So 2n plus 1 becomes multiplication. Pi 2n times pi power 1. This is what I do. Yeah?
And then here, you do the same as you did there.
What did I do? I didn't do anything. Here, this one.
Yeah.
You don't need 2n. You need n.
Right.
So you use this rule.
Like you say.
Yeah? So pi 2 and then power n.
But we already have a pi there.
Where?
Yeah, you took it to a constant.
Ah, here? This is a constant. You
Oh,
can
I
just
didn't see it.
kick it out. Ah, yeah, this is a constant. It's
Okay,
here.
okay.
It's here. I kicked it out. I
Yeah.
put it here. Okay? Let's do maybe telescoping.
Yes.
Let's do telescoping. Telescoping series basically usually written as a difference. Usually written as a difference. So it's not something power n. Yeah? It's just a difference between two functions. Let me show you an example. An example of telescoping series would be the following. Summation n equal 1 to infinity of tan inverse power n plus 1 minus tan inverse of n. This is a telescoping series. Why is it a telescoping series? Because it's the difference between two terms. These terms are the same thing exactly, but they're just off by what? This and this are off by how much?
Plus 1.
So the difference is plus 1. Yeah, just take it as a positive value. Okay? Make it positive. Good? Okay. How do we solve any telescoping series? How do we determine if it converges or diverges? There is no rule for that. You're going to write the partial sum. What's the partial sum? We're going to write it down. And then we're going to take the limit of the partial sum. So the sum of any telescoping series, S equals the limit, n goes to infinity of Sn. Okay? Sn is called partial sum. شو يعني partial sum? We will see. Just give me a moment. Okay. So the difference is 1, right? You agree that the difference is 1, everybody?
Yes.
Between this guy and this guy. How do you go from n to n plus 1? You just add 1. Okay. I want you to double that difference. So how much do you get?
Just 2.
So double the difference.
You always double or just
Yes, you always double. You see in every question we do it's the same. So we get 2. I want you to do something. You write. Because the difference is 2. Sorry, because when you double it, you get 2. Write 2 constant terms. And then 2 n terms. I'll show you what this means. Just give me a moment. Why is that? Because the difference is 2. So 2 constant terms and 2 n terms. Okay, what does that mean? The partial sum. Let's write the partial sum. Okay. You start from the beginning. How do you write the sum of a series? You plug. Plug 1. What do you get? Tan inverse of 2 minus tan inverse of 1. Am I right? This is one term. N equal 1. Plug another term. The next one, right? N equal 2. Is it clear? I plugged the first 2 terms. N equal 1, N equal 2. That's it. Is this step hard? Plus. Keep going, but you don't write this. You just literally write plus, dot, dot, dot. Plus, I want you to write 2 more terms. But they're not constant terms. They're like the n is not a number. N is n. You write it as n. Yani, how do you do that? You take this, copy, paste here, in the last term. So what do I have? Tan inverse n plus 1 minus tan inverse of n. Good?
Yes.
Now this is series. The incrementation is plus 1, right? Like n1, n2, and blah, blah, blah. So if I want to go backward, I subtract 1, right?
Yes.
So tan inverse of n minus tan inverse of n minus 1. I subtracted 1. Yeah? Okay. This is the partial sum now. You will see cancellation. You have to see cancellation. Look. Tan inverse 2. Tan inverse 2. Cancel. Tan inverse n. Tan inverse n. Clear? So we cancelled, right? And what will happen here? This one will cancel with the terms in the middle. There are some terms in the middle. You don't have to write them. But let me tell you, if you go back one step, wouldn't you get tan inverse n minus 1 plus tan minus tan inverse n minus 2 here? So this cancels. And then if you go in the next term, what's the next term? Tan inverse of 4 minus tan inverse of 3 cancels. So who survived in the end?
Tan 1.
Negative tan inverse 1.
Sn equal tan inverse 1 negative plus tan inverse of n plus 1. How many times survived? How many times survived?
2
2 times. It's not a coincidence. You have the surviving terms are these. This is the number of the surviving terms, 2. Okay? You have to end up with 2 terms in the process and then. It's clear? Okay? I'm doing it slowly, but you can do it way faster than me. And then finally,
Then we just subtract and put the negative out.
no, what do you mean? Khalas, I'm done now. This is the partial sum, right?
I'm saying we have a negative there. Can we just do tan inverse minus tan inverse n plus 1?
No, the negative is for this one, so you can do tan inverse n plus 1. Is this what you're saying? Minus tan n plus 1?
Yeah.
Okay, sure. So this is the partial sum, right? What do you do now? Sum equals
Limit
n goes to infinity of the partial sum. There is no way to know if the series converges or diverges until you reach this step. Okay? So what do you get?
get pi over 2.
Tan inverse of infinity is pi over 2. You can try on the calculator. Tan inverse of 1 is just a number. I think it's pi over 4. So the answer is pi over 4. So the sum of the series is pi over 4. Therefore, since the sum is a finite number, it converges. Is it clear?
Yes.
There is a couple of harder examples which we'll do them next time. Okay? Let's do the quiz. Yeah?